Our project topic is design a HDL-based real-time control systems using FSM, PWM, and dynamic counting logic. Description: an HDL-based real-time control system means using a special language called hardware description language, like Verilog or VHDL, to create digital circuits. These circuits are then put onto devices like FPGAs, Field Programmable Gate Arrays, or ASICs, application specific integrated circuits. Instead of software running one command at a time, these hardware circuits work in parallel, which means they can handle multiple tasks at once very quickly.
Project breakdown. We have break down our project into four different parts. The first part is FSM design and control logic, responsible for designing the finite state machine that governs the overall system behavior. The second part is responsible for PWM signal generation module, handles the generation of pulse width modulate signals and controlled by the FSM. The third part is dynamic counting logic and timing control. Focus on creating counting and timing logic to facilitate real-time controls and event scheduling. At last, the fourth path is integration testing and documentation. Integrates all modules into a QoS system, performs system-level testing and validation. Project distribution. We have distributed our project into four different parts. As per our team consists of 4 members, we have distributed into 4 different works as the project breakdown.
Compound. In our project, my role is to define system states and state transition conditions. FSM stands for Finite State Mission. It's a model used to design the control of a logic system. It defines how the system moves between different states based on inputs and conditions. We use an FSM to make the system's behavior organized and predictable. Instead of reacting randomly, the FSM ensures the system follows a specific sequence of its operation. The control logic generates the signals that control other parts of the system. Depending on the current state, it decides what modules should be active, what data to send, or when to eat. And my role is in our project is to design the PWM signal generation module. PWM stands for pulse width modulation. It's used to control the amount of power delivered to a device. For example, controlling the speed of a motor or brightness of an LED. In my HDL code, I am using counters and comparators to generate a square wave signal with a variable duty cycle. The FSM controls the duty cycle, so when the system changes state, the PWM output automatically adjusts.
Hi, I am Charles Ujjwal. In our project, my role is to design the dynamic counting logic and timing control module. I should develop programmable up or down counters in Verilog that help control the timing of the system. My module sends timing and delay signals to the FSM and PWM so that all operations happen in sync. I should also make the counters dynamic, meaning their behavior changes based on the FSM's command like start, stop, or reset.
Hi, my name is Tushar Sharma, and in our project, my role is the FSM controls when the counter runs and resets based on system state. The counter counts clock pulse and provides a value that determines the PWM duty cycle. The PWM model compares the counter value with a set threshold to create the pulse width modulate signals. The modulate shares